Why is non-invasive BCI signal-to-noise low? Imagine trying to listen to a whisper in a crowded room. That's similar to what happens when non-invasive brain-computer interfaces try to pick up brain signals. These systems don't use surgery or implants. Instead, they rely on sensors placed on the scalp. The most common method is electroencephalography, or EEG, which uses small electrodes on the head to detect brain activity. But here's the catch. Signals from the brain have to pass through many layers before reaching these sensors. The skull, skin, and tissues all act like filters, weakening and blurring the signals. This makes the brain signals much weaker compared to the background noise. On top of that, the body produces a lot of electrical activity that can interfere with the signals. For example, muscle movements from talking or blinking, eye movements, blood flow, and even the heartbeat generate electrical signals that mix in with brain signals. These are called physiological noises. External sources like electrical devices, fluorescent lights, or radio signals can also add unwanted noise to the recordings. All these factors combine to make it hard for the system to distinguish real brain activity from the noise. Another reason is the limited spatial resolution of non-invasive methods. Since sensors are on the scalp, they pick up the combined activity of large groups of neurons, not specific tiny areas. This makes it difficult to identify precise signals from small brain regions. Plus, movements, sweating, or poor contact between the electrodes and the skin can create artifacts. These artifacts are false signals that further muddy the data. Despite these challenges, non-invasive brain-computer interfaces are still popular because they avoid the risks of surgery. They can capture brain activity very quickly, often within milliseconds. Researchers are working on better signal processing techniques, smarter algorithms, and improved electrode designs to boost the quality of signals they can extract. They are also exploring new ways to combine stimulation with non-invasive methods to improve signal clarity. In the end, the main reason for the low signal-to-noise ratio is the physical barrier of the skull and tissues, plus the many biological and environmental noises that interfere with the signals. Overcoming these issues is a big focus in neurotechnology, aiming to make non-invasive brain interfaces more accurate and reliable for everyday use.